Well, that's my point. I don't know. And Mr. O'Brien, the guy who runs tech, Joe O'Brien, I don't know if any of you have ever met Joe. He doesn't know why it won't do either. He did not make a setting on the Chromebooks to block live streams. So we have no idea why you can't watch the live streams on the Chromebook. So the answer to why, nobody knows. Well, somebody knows, but nobody around here who has any authority knows. All right. Guys, here's what we're going to talk about today. We're going to talk about modeling quadratics. I think, to me, in the 10 or 11 years that you guys have been doing math, this is probably the most interesting thing that you've ever seen. And here's why. Everything that goes up in the air, Justin, catch. Quadratic. That was a parabola when I threw the ball to Justin. It was a parabola when he threw it back to me. Everything that moves on Earth without being pushed, in other words, no motor pushing it through the air, no parachute keeping it from falling, everything that flies through the air on Earth or in any gravitational field travels in the shape of a parabola. Which means that if you kick a football, throw a ball, shoot a rocket, as soon as it leaves your hand, as soon as the rocket motor shuts off, it travels in a parabola. And if it travels in a parabola with a minimum amount of information, we can find the equation of that parabola. And if we can find the equation of that parabola, we can then predict what's going to happen. We can say at time such and such, it's going to be here. Because we know the equation of that parabola. This is super, super interesting to me. My degree is aerospace engineering. That's what I did at University of Washington. Rockets, space travel. And so to me, this is super interesting. The idea that you can take a little bit of data and you can somehow write an equation that tells you what's going to happen. Because now, once I know what's going to happen, I take the same rocket out into that field, I can tell you exactly where it's going to land. Now, we have to make some simplifying assumptions. We're going to assume that there's no wind the day that we do it. There's no wind any other time we shoot that rocket off, that the rocket motor works the same every way. We do have to make some simplifying assumptions for this basic idea here. But the fact that we can say with pretty certainty, hey, this is the path that this is going to travel, and every time it happens, it's going to happen the same way, and here's the equation. So let's look at a fairly simple situation. Here's the ground. You know, having ground is good. In the ground is a fence, and the fence is 3 feet high. Over here, 4 feet from the fence, a jackrabbit leaps over the fence. You guys know what a jackrabbit is? They're very large rabbits. They're mostly found down in Texas, Oklahoma, that area. They're plains rabbits, but they're large, like huge rabbits. They're not like little tiny ones we get here. So, a jackrabbit, I'll just in advance, no making fun of my drawing, because I never claimed to be an artist. Jumps over the fence. Still look like a rabbit? Okay, good. He just barely clears the fence. And we specify that so that we can say that the very top of that is exactly 3 feet high. Here's the first thing we need to do. we need to put a set of axes on this problem. An x-axis and a y-axis. Somebody want to pick an x-axis and a y-axis? Dominic?
The y-axis is the fence and the x-axis is the ground.
Are there any other choices? Could we have put it anywhere else? Is that a hand, or are you just scratching your head? Dominic?
Could have put it where the rabbit is.
Guys, here's the beauty of this kind of problem. Put it anywhere we want. It's our problem. There are advantages and disadvantages to both. We could have put it down here, which would have been really stupid, but we could have. But these are the two obvious choices. Put the y-axis right in the middle, or put the y-axis over where the rabbit is leaving the ground. So because Dominic chose the first one, we're going to use it first. We'll talk about a problem with the other one. So here's the question I have next. What x comma y points do I know on this graph? So go ahead and think about that for just a second. What points do I know that are on this graph that I could label right now? X comma y. What numbers do I know on that graph? Xander, you got one? Give me a point on that graph.
3 feet.
Okay. What is the point? What are the coordinates of that point right there?
0, 3.
Perfect. Do I know anything else about that point?
I don't know.
What do you think? What else do I know about the point 0, 3? What do we call that on this parabola? No? Daniel? Yeah. Because that's the vertex of my parabola. Because it is the highest point that the rabbit reaches as he's on his way up before he starts to come back down again. Good. Good. Thank you, Xander. Thank you, Daniel. Eduardo, give me another point on this graph. -4, 0. Good. Good. What do we call that point, Eduardo? Yeah, that's one of the x-intercepts. Tucker, give me another point on this graph.
4, 0.
Oh, what do we call that point?
X-intercept.
Yeah, there's the other x-intercept. So we have 3 points on this graph. Now, let's think about the equation of a parabola. The equation that we have been working with day after day after day for the last few weeks is y equals a times x minus h squared plus k. I don't want to be writing this down because this is an example of the problem that we're going to be doing over and over. Just looking at the problem on the board, do we know the values of A, H, or K? Luis?
Yeah.
What are they?
4 and 3.
Why? So 4 and 3, and where would they go in the equation?
The H would be, the 4 would be for the H and the 3 would be. I'm not sure how to word it out, but the H's were like the sides and the A's were going up and down the
I agree with everything you've said except for one thing, and that's the value of h in this problem. You are right. K is up and down. This parabola has been shifted up 3 points, which means that K is equal to 3. But has it been shifted left or right? And the way you tell is by looking at the vertex. The vertex of a regular parabola starts at 0, 0. What did we do to this parabola? We moved it up 3. We didn't move it over at all, no left or right, and we flipped it upside down. Does that make sense to everybody? Here's our regular parabola. Quick graph parabola, 0, 0, 1, 1, 2, 4. We flipped it over, we slid it up. I can't go up very far without getting a chair to stand on. But does that make sense? That our parabola started like this, and now it's like this and slid up. H is equal to?
Oh, H is 0.
H comma K is always the vertex. Always. 100% of parabolas. H comma K is the vertex, which means I can write this equation, y equals a times x minus 0 squared plus, whoops, not 4, 3. Plus 3. Hey, look, I'm 2/3 of the way done with this problem. I know H, I know K. What's the only thing I don't know? Stretch factor. I wonder if we could just have a stretch factor of -1. I mean, it's upside down. We know it's got to be negative, right? Let's do a quick graph. Here we go. Ready? There's my vertex. Where's my first quick graph point? Eliana? Over 1, down 1. Over 1 takes me to 1. Down 1 takes me to 2. Where's my next quick graph point?
Over 2, down 4.
Over 2, down 4. So that takes me to 2 halfway, and I'm already down here. Guys, are we all comfortable with the fact that this definitely is not a regular parabola? It's squished. It's wider. It's got to have a value of a, and we don't know what the value of a is, but it definitely isn't 1. So we got a problem there. We got an unknown. So here's a question. It sort of goes back to something I said earlier. Do we know anything about those? What could I plug in to this equation for x and y? Anything. Well, let's restrict that a little bit. Anything that's on the graph, agreed? Do we know any values of x and y that are on that graph? Which ones, Eduardo? -4, 0, for example. 4, 0, for example. 0, 3? Yeah, but here's the problem with 0, 3. Let's plug in 0, 3. 3 equals a times 0 minus 0 squared plus 3. What's 0 minus 0? 0. What's 0 squared? 0. What's a times 0? 3 equals 3. True, but completely useless. Here's the thing. We already used that point. We're not going to use it again. We already used it. We're done with that one. Never think about it again. Instead, we'll use one of the other 2 points. We'll use Eduardo's suggestion, and let's plug in -4, 0. Here we go. 0 equals a times -4 minus 0 squared plus 3. There's my point right there. Okay, let's simplify. Negative 4 minus 0. Negative 4. Negative 4 squared. 16. 0 equals a times 16 plus 3. How do I solve for a? First step, Daniel? I want to get a by itself. What do I need to do here? You sure? You're right. You just sounded unsure. So yeah, absolutely, yes. Subtract 3 from both sides. Negative 3 equals a times 16. Justin, what's the next step to solving for a?
Make y 0.
There's no y.
Or the negative 3.
Make the negative 3 0?
Alright. Do it.
Well, I don't know. How would I make the negative 3 0? What would I have to do to make that 0? But that would take me back to here. So that would undo what Daniel just told us was our first step. How do I get a by itself? What do I got to get rid of to have a by itself?
16.
And what operation is that 16 doing right now?
Divide.
How do I get rid of a multiplying?
Divide.
What am I going to do?
Divide by 16.
Boom. Good. Divide by 16. Guys, I know this one actually is a little confusing because if I said 16a equals negative 3, do we agree that we would all have immediately said divide by 16? But that's just 16 times a, and a times 16 and 16 times a are the exact same thing. Doesn't matter what order you write them in. This one, it just so happens that the 16 is over here because it was a times the parentheses. Right? Good. Hey, if a is equal to negative 3/16, can't I write my equation now of this parabola? Y equals a, negative 3/16, times x minus 0. Do I have to write minus 0? No. But you know what? I'm gonna, just because it reminds me that h is 0 and k is 3. Hey guys, that's the equation of the parabola that rabbit makes when he jumps over the fence. So let's talk about the steps. Step number 1. Draw a graph. Can be a sketch, doesn't have to be nice, but it should have all the things that you know labeled on the graph. Step number 2. Plug in the vertex. Number 2. Vertex. Can you guys see this orange? Seems to be running out a little bit. Tell me if I write stuff on the board and you're like, Mr. Armour, we can't really see that. Tell me and I'll throw that pen away. Step number 3 is plug in a point. It's getting fainter and fainter. Plug in a point. I'm going to change colors and throw this one away. I'll change to blue. Plug in a point. Guys, that point on these kinds of problems is almost always going to be one of the x-intercepts. Mostly. Every once in a while you get a problem where it's different. Step 4. Solve for a. Wow, this one's not going to. And step 5 is write the equation. Anybody ever gone to IKEA and bought themselves one of those bookshelves that just come with a bunch of pieces and then you have to follow the directions in order to put your bookshelf together? They give you a little wrench. No? None of you ever assembled a piece of furniture?
I've never bought anything at IKEA.
Well, they sell them probably sell them at Walmart and Fred Meyer too, but IKEA is sort of they're the ones that came up with that. The idea that you could go there and you buy furniture that was unassembled and then you just bring it home and assemble it. Plastic models, glued them together. Because the point of all of that is that there's a series of steps that you follow. Step number 1, using these screws, screw the shelves to the side piece. Step number 2, screw the other side piece to the other end of each of the shelves using more of the screws. Step number 3, attach the backing. If you try to attach the backing when you haven't attached the shelves, you don't get the right answer. Mathematically, this is the same thing as a set of instructions for building something, or putting together whatever it is you have bought. A little soccer goal that comes bundled up and you have to assemble it. All right? So, we're going to be doing this a lot over the next few days. Following those instructions. Let's do another problem. Any questions about the process or the problem? No, we good with that? Pretty straightforward. The hard part? Probably remembering that that's the vertex. And that that's a point on the graph. If you can remember that that's the vertex and that's a point on the graph, then this is a really simple solve a problem algebraically, is it not? 2-step, like Daniel said, subtract 3 from both sides, divide by 16 as Justin gave us. Which is a 2-step solution. All right. Let's talk about model rockets because, that's what I like. Anyone ever fired off those model rockets that have the little powder engines? You put wire in them and you got a little launcher control that's battery powered. Danny, you nodded, yeah, you've done that?
Yeah.
Those are so much fun. We used to do them over and to the extent that we could afford to keep buying the little model rocket motors because they weren't super cheap. But you'd build a rocket and you could put a motor in it and you'd launch it and then you'd hope it didn't like drift over and land in the trees because then you just lost your rocket and you had to start over again. And those were more expensive. Man, those were fun. Set them all up and off they went. Tons of fun. So here's what we're doing. We're launching a rocket. Here it is on its little launch pad. Look at that, it's got fins and everything. When you press the go button, flames come out. And off it goes. It shoots up into the air. What kind of shape does it make? What shape is that? Parabola. Yes. Because it's always a parabola. Things that fly through the air make parabolas. This rocket lands 1,500 feet away from where you launched it. And it reaches a maximum height of 1,200 feet. Man, this is like the 4th time I've taught this in the last month, and I really, 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 really want to go to a model store and buy a model rocket and shoot it off. I might have to at some point here. Got to find a store that sells these kinds of things. Make ourselves some space to work here. All right, first question, where are my axes going to be? Because the first thing I need to do is make this into a graph. Where would you put them? Think about where you would put them. Dominic,
In the center.
you could put them in the center. You could. This is not actually a situation where my favorite place is in the center. The rabbit, it was sort of obvious because we knew that he was leaping over a fence. Well, what's in the center of this rocket problem? Nothing. Except that while it was flying, it happened to cross through some bit of space that was right in the middle. What I like better about this one was actually Dominic's second suggestion on the rabbit problem, which is let's put the axes let's start them, the origin where we launched the rocket. Here's the nice thing about it. That tells us that that's 0. I can set up my axes before I shoot the rocket. If I have to know where the vertex is, I can't set up my axes until after I've shot the rocket and collected all my measurements. Whereas now I could draw this thing without knowing anything about how high is it going to go, how far is it going to fly. I've already drawn my graph, and as soon as I collect my data, I go over and I jot down. Here's where it landed. Here's how high it went. We cool with that? Does that make sense? All right. So here's what I need. I need coordinates of the vertex so that I can plug them in. What are the coordinates of that vertex? And this requires a little bit of thinking about what you know about parabolas. Tucker?
Is it 750?
You asking or telling?
It's 750.
Why?
Because it's halfway between the starting.
Symmetry, exactly. The vertex is always halfway between the intercepts. And so half of 1500 is 750, which means that my vertex is at 750 comma what, Tucker?
1200.
Boom. Jared, where do those go in my equation?
750, 1200. 750.
There it is. Step 2. We found the vertex. We can plug it into our equation. Y equals A times X minus 750 all squared plus 1200. Pretty straightforward. Good. Step 3, plug in a point. Good. I need more points. I need more points on this graph. Eliana, where are some more points on this graph?
0.
Oh, careful. 0 comma 1500 will be up here. So this must be 1500 comma 0. Yeah, it's always X and then Y. 1500 comma 0. Is there another one? Another point on this graph?
0,
0, 0, because we decided when we set this up to make that 0. Now, it makes no difference at all which of those 2 points you plug into here. 0 minus 750, negative 750 squared. 1500 minus 750, positive 750 squared. We get the same answer either way. So step 3 is 0 equals A times, I'm going to use the one Eliana gave me first, 750 squared plus 1200. Now we're going to do a little simplifying. 1500 minus 750. Anyone? 750. We already knew that because look, it came from the halfway. So we didn't even have to recalculate. 0 equals A times 750 squared plus 1200. We all learned our 75 times tables at middle school? Yes? So we all know what 750 squared is? Anybody? Anybody? 75 times tables? What? Nothing? Yeah, me neither. Calculator, go! Somebody calculate for me. Somebody with a calculator out in front of them. I need 750 squared. Go, 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 go. Who's getting it? Eliana, you there?
I got it.
Oh, you got it? Go.
Big number. I don't know if I did that right. I think I did it wrong.
Well, tell us your number and then we'll confirm with the other people.
It's 562,570.
So what you got, Dominic? 562,500?
Yep.
Oh, hey. You know, just for fun, did you know that that means that 75 times 75 is 5,625?
You do that on your own.
No, I just looked at this. Because if I just add two zeros to make it 750 times 750, then I just add two zeros to the 5625. So commit that to memory. I might have a quiz on 75 times tables. Kidding. I wouldn't do that to you. It would be mean. All right. First step to solving. Daniel. Subtract 1,200. Good. I got negative 1,200 equals A times 562,500. Justin, second step to solving.
Divide by 500,000, not the big number.
Divide by the big number.
Yeah.
Negative 1,200 over 562,500. You guys know that I very intentionally ask the same people the same question every time, or sometimes like that. I've done it to Eliana, I've done it to Daniel, I just did it to Justin. Notice that the second time that I ask, they just know what the answer is. They don't have to think about it or wonder whether it's right. In case you're wondering, is that accidental? Did you just happen to ask them? No, it's totally intentional. Hey guys, what goes evenly into both 1,200 and into 562,500? 100. That's what those two zeros mean. Hey, guess what? I can divide the top by 100 and I can divide the bottom by 100 and those zeros will go away. And I get A is equal to negative 12 over 5,625. You will never, when will you do it? What did I say? Never. Good. Never. That's 4 times, including Eliana's. 4 nevers. That means it's serious. Turn that into a decimal. The reason we will never turn that into a decimal is because a lot of the time when you turn that into a decimal, you have to round it off. And as soon as you round it off, it's not the equation of that parabola anymore. It's an equation of something sort of near that parabola. And I don't want you to give me the equation of something sort of near the parabola. I want you to give me the equation of the parabola. See the difference? There's nothing wrong with the number 12 over 5,625. Actually, turns out this one will simplify more. What are the factors of 12? Anyone, go.
144.
44?
144.
Factors? Other way. You're squaring. I want a factor. 2. 2 and what? 6, yeah? Go deeper. What are the factors of 6?
3.
And?
4.
No, 4 is not a factor of 6.
Oh, 6.
Oh, you guys are killing me. 2, thank you. Yeah, but there's 2 of them. Guys, the factors of 12 are 2 times 2 times 3. That is fully factored, agreed? As far down as you can go. 2 times 6 is factored, but it's not fully factored. You got to keep going. Now, here's a question for you. 5,625. Is 2 a factor? No, definitely not. Is 3 a factor? How do you know? You guys know the trick to tell if 3 is a factor of 5,625? You add the decimals together. 5 plus 6 plus 2 plus 5 equals what?
8.
Is 3 a factor of 18? It is. Therefore, 3 is also a factor of 5,625. Cool, huh? That's all you do. You add the decimals together, and if 3 goes into that, then 3 must go into that. So let's divide this by 3. 3 times, well, goes in once into 5, remainder 2, agreed? And it goes 8 times into 26, remainder 2, agreed? And it goes 7 times into 22, remainder 1, and it goes 5 times into 15. $5,625 divided by 3 is 1,875. Just go decimal by decimal and then carry the remainder. I don't think they teach you that at school anymore. That's called short division. Remember long division where you wrote it all out and then went down? This is called short division. You're doing the same thing, but instead of putting the remainders down below, you just carry the remainder up to the next line or to the next decimal. Hey, guess what? That means that I could write this as negative 4 times 3 over 1875 times 3. Anything reduce? There's a 1. I've just simplified this as far as it'll go. It won't go any further because we know that 2 doesn't go into 1875 and 2 is the only factor of 4. So we're done. Last step, write the equation. Here we go. Let's write an equation. Y equals A, negative 4 over 1875. By the way, I won't require you to simplify these. If you wrote this problem as 12 over 5625, I'm okay with that. If you wrote it as 1200 over 562,500, I'm okay with it, but less okay, because it should be really obvious that if things end in 2 zeros, are both divisible by 100. You should always be able to, on a fraction, cross off those zeros. X minus 750 squared plus 1200. Guys, there's the equation of my rocket. I can now predict to you anywhere from here to here where that rocket will be, what the height of the rocket will be at some value of x. So if I said to you, okay, walk out in the field, I want you to stand at 850 feet away. When the rocket passes over your head, you can calculate how high up it'll be. Why would you want it? In this case, you probably wouldn't. But the point being that we can now predict the height of the rocket at any place in its path. We cool with that? Any questions about the process? Does everybody have this written down? Okay. There's a worksheet that you're going to do during T3. It's got 2 problems on it. One of them is somebody kicking a soccer ball, so it's gonna look just like this. The ball goes up, the ball comes down. The other one is a skateboard park shaped like a U, shaped like a parabola underground. And your goal is to find the equations of both of the parabolas. Guys, as you're doing this, follow the steps. Look back at the examples that you've been taking notes on. You know how to do each step, and if you follow it step by step, you'll be able to pretty straightforwardly find these equations. Any questions about what you're doing? Any questions about whether it's okay to convert the stretch factor into a decimal? Correct answer is no. Leave it as a fraction. There's nothing wrong with fractions. All right. It is called classwork number 3. It is in Google Classroom. I'm going to go ahead and shut off this live stream so that I can play music.